So we've said that a census in practice is not actually going to achieve our goal, right? A census is not going to allow us to calculate our demand because we're not actually going to get the whole target population, and we're going to be missing systematically some parts of the target population in a problematic way. So is this always the case? Is it always the case that we can't just calculate the target or calculate the demand? Well, actually not, especially recently, especially in the last, say, 5 or 10 years. I'm guessing you've heard terms like big data or data science. So actually, now that there's so much data being collected automatically all the time, it is not uncommon to have a case where you do have all the data in the target population. Not all examples involve having a few mice, having a few bags of dirt, and having a few people. For example, suppose that you are an intern at Amazon, and your job is to figure out the average price that people paid when they bought shoes at Amazon in the month of December, okay? Well, you can literally find, stored in Amazon's data, right, the amount that people paid for every single transaction that occurred in that month for shoes, right? That is findable. The entire target population is there, right? If the target population consists of transactions, the units are transactions there. All of those transactions can be found. And once you find them, you can literally take the mean of the price that people paid for shoes in that month and report it, and that's your demand. So for very big data sets in the modern world, sometimes we can just calculate the demand because we do have all the units in the target population observed. So why is data science still hard? Why is that not easy? Well, imagine you really were that intern at Amazon. I don't know how to start finding all those shoe transactions, right? That's hard. The computing side of that is really hard. There are a lot of transactions at Amazon. How do you go about, you can't just, for example, open a little Excel spreadsheet on your personal computer and do that calculation. There's way too many, right? So the computing challenge to finding all those transactions and calculating the mean is not straightforward. With big data, the challenges are about summarizing the data, about finding the data, about cleaning the data, about managing the data, and about figuring out what can even be learned from the data, but not about the fact that you have a subset of the target population, because in a big data scenario, you usually do have all the data, actually. Okay, so there's this big distinction in terms of what kinds of methods are needed, what we as data analysts can contribute if you are working on a study for a psych professor where you have a sample size of a couple hundred, and that is a subset of all human beings who ever lived, right? Versus if you are this intern at Amazon and all the data ever is out there, if you can just figure out how to use it. So that's important, right? And that's a change from the way statistics has often been taught in the past. And I want you to know that as we go forward, for a lot of the things we say in this course apply only to the sampling case and not to the big data case, right? When we talk about things that I know you've heard of in your IntroStats course, we talk about hypothesis tests and p-values. When we talk about confidence intervals, this idea of uncertainty, any of those things, the idea that our data set might be different than the target population leads to those things, leads to hypothesis tests, p-values, confidence intervals. None of those things apply at all if we have a big data set that actually includes every single transaction, right? You don't need a confidence interval around a number that you actually know. And we'll define these terms, p-value and confidence interval, as we go, but I'm also expecting that they're familiar to you right now. So that is something for you to know. There's also lots of things we'll talk about in this class that do apply to big data, such as visualization, data cleaning, data management. There's plenty of things that we still can make progress on. I'm going to draw a little schematic, hoping that it will help you. So we said that what we really want is the whole target population. And if we had the whole target population, then we could just calculate the demand. Usually we can't, but if you are in a big data scenario, like you're an intern at Amazon, then actually you can go directly from the target population to your estimand. Again, the challenge is computing. So if you were an Amazon intern. I used to use an example of an intern at Target, but that was confusing, I realized, because Target is the name of a population, but also the name of a store. So we're going to go with Amazon now. All right, so we've got that, right? But often you can't do that. So we take this detour into data that we actually have. How do we do that detour? Well, we said that was sampling, right? We're going to talk more about that. How do you get from a target population to the data we actually have? And then once you have the data that we actually have, once there's a data set in front of you, somehow we have to use that to learn something about the estimand. Are we going to be able to just calculate the estimand? No, right? Like if I have a subset of the people who live in the US, if I have a subset of households and I know the incomes of say 1,000 households, I can't just calculate the average income I would get if I had all possible households. If I have a sample of 50 Wellesley students and they told me what they think of remote learning, I can't just use that to calculate exactly the number I would get if I had every Wellesley student. If I have 15 bags of dirt collected from the Wellesley campus, I can't use those to exactly calculate the concentration of some particular substance across the entire Wellesley campus's dirt, right? I can't do that. You can tell I'm not an ecologist here, but I'm making up terms, but I've heard a lot about these studies of bags of dirt at Wellesley. So we have to somehow take the data we have and do our best to learn something about the estimand, and that process is called statistical inference. And that's where we get p-values, confidence intervals, Bayesian statistics fits in here as well. Anytime we're trying to get from a data set to an estimand, but our data set is not the entire target population.